All right, everyone. Thank you so much for joining us. Welcome to CodeMonkey's webinar, Coding Adventure in Your Classroom. Thank you for joining us this afternoon. Please follow us on Twitter at CodeMonkeySTU or on our Instagram. Also, please tweet at us today during today's webinar at #CodeMonkeyWebinar. We will do our best to answer any live tweets. During today's webinar, my team is also here to answer any questions that you may have. And then following today's webinar, we'll send you information regarding your PD certificate. So let's get ready to write code, catch bananas, and save the world. So I always like to start off the webinar discussing about who I am. So I'm sure you're wondering who I am and basically what I do. So my name is Leena Saleh, and I'm the Professional Development Manager here at CodeMonkey. I have 10 years of education experience, actually a little bit more now. 9 of those years I spent in the classroom. I was a former STEM teacher in which I developed curriculum across my district for grades K through 12. Oh, I'm sorry. Sometimes you get so excited when you're moving through that you forget the extra part. So back to school webinar with Coding Adventure in Your Classroom. So I just want you to be able to see the slides. Now you can be on the same page with me here. So my apologies about that. Anyway, so I'm a former STEM teacher. I help write curriculum for K through 12 for our district and scaffolding what that looks like. I'm also a professional development leader. So what that means is I've done workshops prior to my role here at CodeMonkey in of my districts and out of my districts kind of across the country. I'm also an organizer of EdTech Austin, and so we basically marry the partnerships between teachers and the local EdTech scene and kind of create for that kind of seamless partnership. I'm also very passionate about computer science. Those that know me and those of you that don't, both my parents never graduated from college or never even went to college, and I just didn't know that that was there. I just always thought that science was with computers, and I never really understood what that was. And so I'm just passionate about creating that opportunity for students and knowing that coding is not just for one, but for all. So I think that's pretty important. You can always tweet at me here at Lena at CodeMonkey Studio, or at CodeMonkey, sorry, excuse me, or you can email me for any questions or anything that you might have from today's webinar, or maybe some thoughts that you have after our webinar today. So thank you once again for joining us, and we're gonna go ahead and get started here. Oh, sorry, before we get started though, I do want to introduce our panelists here. On the left-hand side in the red jacket, we have Zoe. She is our marketing and media manager. And on the right-hand side, we have Talya. She's the customer success manager. Both really awesome. They're joining us from Israel, which is where our main office is located. And so it's midnight for them. So thank you so much for taking that time to join us today, both of you. So now let's kick it off and let's get started. So today we're going to review how to run a lesson in your classroom with Coding Adventure. We're going to go into the intro to Coding Adventure itself, what a Coding Adventure is, what language we use to code in. Then we're going to use Coding Adventure with our new feature, CodeMonkey Lessons, which is our, oopsies. Didn't mean to do that, which is our new mode that we can use. So we're going to discuss what it is, the interface, the layout, and then we're going to work through lessons 1 and 3 to get you started with this year fresh with Coding Adventure. How to track students' progress, some of the key concepts that are intertwined within there. And we're going to talk about skill mode and why we use it, some new features and new courses that we have here at CodeMonkey, and then we're going to leave some time for you at the end for Coding Adventure. For questions. All right, so Coding Adventure in your classroom. So what is Coding Adventure? I'm sure many of you already know, but if you don't know, I like to always review what Coding Adventure course is. So Coding Adventure is for grades 3 through 8. It's a game-based course with 200+ coding levels, both in story mode and skill mode, which we'll discuss, universal coding concepts that go across any coding language. It teaches that text-based coding, which is CoffeeScript, which we'll talk about here in just a minute. And then there's no prior coding experience that's needed to begin. It's very scaffolded and goes linearly, very interactive. The kids are very excited about it. And they really enjoy making the monkey catch the banana, which we'll do today. So what is CoffeeScript? What language is it? Anytime I'm at conferences or even students asking me what CoffeeScript even is. CoffeeScript is a real computer language. Real people do use it. So you can look it up and Google it at any time. It is a shorter version of JavaScript and Python. So think about like the meat and potatoes of the language. It's very clean. There's no like syntax tying it down or curly brackets or any of that kind of thing. We know, and you know, that students have a really hard time putting periods in, and asking them to do a semicolon is even more challenging. And syntax, especially when you're a new coder, really is the thing that really ties you down. And so CoffeeScript really makes it easy for that seamless transition to whatever next language you want to learn. So let's get into coding adventure using the CodeMonkey lessons. So first, what are the CodeMonkey lessons and what is it that I'm talking about? And so CodeMonkey Lessons, like I said, is our newest feature. It is a feature that helps you more easily conduct your coding classes. Oh, excuse me. You can access it from the classroom dashboard. It also gives you the ability to access individualized lesson plans based on the lesson that you're teaching, and gives you the challenges that are associated within those lessons. It's also a distinct mode for when you're teaching and when students play. So we'll take a look at what that looks like. And then it also saves the teaching progress for each class. So it's not just universal for all of your classes, it saves it very specific to each one of the classrooms that you're working in. All right, so let's go ahead and let's take a look at lesson mode itself. So I'm gonna spare you of how we actually get to lesson mode. If you're not sure, we do have a really nice short tutorial about lesson mode and kind of like how to get there and that kind of a thing. But we're going to go ahead here and get started with what is the what the interface looks like. So the CodeMonkey Lessons is set up exactly like our lesson plans. So it has the challenges that are associated with it, with the lesson plan. How it's set up is it is broken into 3 parts. The first part is the introduction. The second part is the playtime, and then it will have certain challenges that are associated there. And then the last part is the debrief. So set up, just like I said, very similarly. Over here on the right-hand side, we see all of the challenges, as well as our reference and character card. And we'll look at all of those here in just a moment. So let's get into the teaching of sorry, just want to move. Sometimes when you're doing these Zooms, you have toolbars that kind of get in your way there. So here, I always like to kick off my school year, really getting students really jazzed about coding. So how do we do that? So I usually introduce with an unplugged coding activity. In the CodeMonkey lessons, there are always some kind of an unplugged activity intertwined within the lessons. So that's just something to keep in mind. Research states that unplugged activities don't make students better coders, but it makes them have better self-efficacy and better vocabulary. So can't really beat that, right? So I feel like it really gives them that background knowledge to really be successful and apply it to the challenges themselves. So this is my most favorite coding activity I do in teacher trainings. I've really been all across the country doing this activity, and teachers always love it just as much as the students do. So I don't really know what the technical name of it, but I'll call it blindfolded coding. So here are the activity directions. So you will choose 3 students in your classroom. So usually when I do this activity, I bring all my students down to like my little presentation area or wherever you kind of have them. And even 5th graders, I had them sit on the floor, didn't matter to me. So I have them sit down, and then I set up 2 like stations. Well, let's just talk about what the roles are. So first you choose 3 students, and I choose 1 student who gives the directions, and I call them like the guide or the mapper. Then I have 1 student who is going to be blindfolded, and they're going to receive the directions. Then you have another student who's the scripter. So really they're like dictating the script and writing it down so everyone can see it. And then the materials that you need. You need 2 bowls. You can do cups. You can do whatever kind of works for you in your classroom. 1 blindfold. And then items to fill that bowl. So I've done it with beads, and that tend to get all over the floor. So usually when I did it in my classroom, I would do it with like unicorn erasers. That was like, you know, the big thing, or those poop emoji erasers, or whatever it is that kind of get the kids excited. And so when I did that, what you basically do is you set up 2 bowls pretty considerable distance apart, making sure there's nowhere for them to trip or fall or whatever. You really want them to be able to trust kind of how they're going. So then you set them apart. The student that's blindfolded can see where they are, not a big deal, makes no difference. In fact, you want them to know where it is. And then the mapper will guide the student, okay, using the code that we have here. So I have very explicit code here: step, turn right, turn left. And then I have students making sure that we determine how they step. So heel toe. So this isn't really part of the code, but it is something that you want to establish, because when students are blindfolded, and when I've done this several times with teachers, and when they're blindfolded and I have not said walk heel toe, then they end up like tiptoeing little tiny steps, or some people make giant leaps. So this is just a way to keep it really consistent, because we really want consistent, concise code. Pick up, set down, and then pour, okay? So then the scripter is going to be dictating this on the board. So the goal is to guide the student to dump the bowl with items into the empty bowl. I notice here that I'm missing a B on this in the spelling thing. So, of course your students would catch that if they saw it, but there it is. And so what we want to have happen is, as you can see here, this set of students here, they're actually in the teacher college. They're doing this activity here, and you can see what starts to happen is that they're very off balance and not trusting really where they are, as well as this gentleman here. When he was doing it, hopefully this kind of goes through, but anyway, as he was doing it, he was very like wishy-washy about where he was going. So really making sure that the students are kind of guiding them and then writing those steps down therefore, so that if we ever were to repeat it again, we could repeat the code. So like I said, they're blindfolded, they're walking, they dump one empty bowl. They dump the bowl with the objects in it, and they walk it over and dump it into the other bowl. And you'll see things start to happen. So it's an algorithm. There's lots of planning that's involved. And then there's also that sense of trust. They really have to trust the direction giver. I've seen this where teachers have actually walked other teachers into the wall. So just some things to kind of keep in mind and kind of watch as your students are kind of going through. But you'll see that you're immediately off balance. So you have to really rely on your senses. So it's just something to really kind of understand as we're kind of going through. And then they walk it over and they pour the objects into the board. So we've seen many different ways that a computer would work. And actually, as the monkey does when we do challenge number 5, it's the first time we see an algorithm. And also some other factors are like an if statement. If something is there, it won't keep walking. As you saw this young lady on the left-hand side, when she was walking, she reached out really quickly to the bookshelves. Even though she knew she was safe, she even saw where the items were. She just didn't trust her own senses. And that happens to you sometimes when you're walking, to the bathroom in the middle of the night. So just some things to kind of go through. And the kids, like I said, love this. So you can introduce it and then have the kids go and do it themselves. They get really jazzed about it. So what better way to get jazzed up about the year than to do some kind of an unplugged activity. All right, so now let's go ahead and let's get moving here. So here I am in lesson mode. And like I said, if you're not sure how to get there, there's many ways. You just do from the classroom dashboard, the See My Classrooms, click on your classroom, and then you'll see it'll populate right into this lesson mode here. So here I am on lesson number 1. And what I'm gonna do is I'm going to begin the lesson. Once I confirm begin lesson, I want to show you what it looks like on the student side of it, because I just think this is an important thing for you to be able to see here. And you can see that, oops, just make sure I share this here. You can see here that it says your teacher will unlock challenges shortly. So that's just really to keep all of your students together. We know how they do, and you know how they like to get super ahead of themselves. So this just really keeps everyone all together in one spot. So let's head back to our teacher dashboard. To our CodeMonkey Lessons. And so I began the lesson and you saw what it looked like on the student side of it. Now let's go ahead and let's take a look at our lesson plans. So I've actually already, hold on. Like I said, sometimes these toolbars make it a little bit harder to navigate here, so we're working here. Okay, so you should be able to see here that I'm on lesson 1. So how did I do that? I just accessed it from on the right-hand side where it said lessons, and it pulled me up the specific PDF that matches with the lesson that we're going to. So the first thing that we see here in the lesson is we see basically a summary about what this lesson is going to be about. So take some time to read on your own. I'm not going to read it with you today. I feel like we're all pretty good at that. Remember, the lesson plans are always just a guide, and they're always designed to be about 45 minutes. So if you're ever wondering about that, that's kind of how each of the lessons are designed. All right, so here we are on the objectives. And so what I do with my student objectives is I always have a coding or a tech notebook. And so I have the students write down their objectives so we can know at the end of the day that we have reached our objectives, or maybe we still need to work or we're kind of struggling on one. So the students are writing these down. So define coding and computer programming, become familiar with the CodeMonkey platform, which we're going to do together. And then we're going to work through challenges 0 through 5 together. So having those students write that down. Next, I have these components here. So the components, under the teacher resources, I will show you those in just a little bit, but they do have these here. So I have the students also do vocabulary work with these. So I want them to know what the functions of step and turn and what they actually mean. So I have them draw a picture and then write an example of what it is in their notebooks. It's always good for students to have extra resources because we all know they're very forgetful when they need to know different things. So then the terms here that we're also going to be focusing on a challenge and what CoffeeScript means. And we just what CoffeeScript means, so you know that as well. Next, we have our standards. Zoe and my team will actually send you where you can find the specific standards, but outside of here, we do have a specific place that you can find the standards if you're not wanting to go and hunt through the lesson plans themselves. Okay, so we are going to go ahead and get started. So here at the very, very beginning, there is an activity, and it's an unplugged activity. Now, I've just kind of modified this a little bit for the sake of today. And so this tells us to play a short game where you place an object in the room. And so to do so, what I do is I usually just display this on the board. I kind of want all my students to kind of work through it together and kind of develop that kind of collaboration, because coding is really not something, it is something you do solo, but really it's about, like I said, failing forward and kind of working through problems together. And so here we will see we have our whiteboard, and it's really important to have graph paper because you really want to know that it's an XY coordinate. The code or the stage itself runs into an XY coordinate, so you just want to kind of make sure that you're keeping with that and making sure that you're entwining that as much as possible. So we're not just guessing where they go, because we don't want our students to just guess either. So here, student A is facing the board, and we want to count the steps. I mean, we want our student A to move. So we see here on the left-hand side that I have a key that I want the kids to kind of follow: step, turn right, turn left. And I also have that it's 1 square equals 1 step. So that's also some graphic like messages. I mean, there's also a key there to kind of interpret that, okay? So student A is facing the whiteboard, and we want them to do something. So here we want our student to turn right and then step the direction. So when we count the squares, we step 5, and then we always want to step the direction in which we face. And then we step 4, because the computer, not that this is my most favorite term, I heard it from a Harvard professor and many coding professors, they like to say that the computer doesn't have a brain, so just something to think about. They think about it as teachers, I hate this word, but being stupid, and that we have to tell it what to do. Not my favorite term to use. I just like to say that the computer can't think for itself, so we need to give it the information for it to do it. So here we are dictating the code for the students to see, another algorithm as well: turn right, step 5, turn left, and step 4. So that's just kind of a way to kind of introduce that. So we do that activity, which we just took directly from the lesson plans. Nothing that like is any different. I just kind of modified it instead of doing an object, and I did it together on the board. Next thing it talks about is the different languages, which we just talked about. And now we get into the playtime. So here this says for the students to log in and kind of play. I don't ever introduce it like that. And I'm not going to specifically assign them the challenges yet, because I want to do something together. So while my students are all sitting there and we solve this one unplugged challenge on the board, I bring all of them down to the carpet. I'm going to exit out of everything, and I'm just going to bring a student up that I know is not super strong. Not an expert coder. I don't want an expert coder. I want someone who the students trust, and that if they make a mistake, they have the ability to not be so flustered and figure out kind of what to do. So I bring up a student. The student's name is Savannah. She comes up to the board, and I step back. I'm completely just turned from teacher into a facilitator. I don't want me to be really involved in the picture at all. So Savannah is going to have to figure out, what do I do? What do I do here? So I don't give her any guidance and I just let her take control. At first, the class is usually super mum until they figure out what to do. So we get our solution here, and now we move on to the next challenge. Now we saw that the run makes him run, and then kind of what we do. So this is all about failing forward. There is no wrong way to do it. There's always a more concise way to do it, but not really a wrong way to do it. So she may see the directions there and do that. She might figure out that she can use this ruler and measure the distance of however she wants to do it. And so here, when students are learning how to code, they often will do it in 2 separate lines. And I will not say one thing. I'll just kind of let it happen. And later it's going to be more of a teachable moment here. Now there's 2 stars and they may start to pick up on it. You'll see here that there's a little tip here, and that Gordo is usually cheerleading or maybe introducing a concept as we go along. So now the students are really getting confident. They're really getting super excited. And if she gets stuck, I ask her to call on anyone in the crowd, but they must give an explanation as to why she should do what she should do. Just gives them a really good way to like start really doing that procedural text writing, or really just to get them to explain their thinking. And so here she measures the distance and she figures it out and she gets to the end. In challenges 3 and 4, it introduces the directionality. So I'm not going to solve this challenge specifically with you because the students start to get the idea, and I stop at 2. And I just want to note something on here because I think it's important. One of my teacher ambassadors, a student shared that with them, and I didn't even notice this myself, is over here on the left-hand side is a watch. And so the watch just helps with the directionality for CodeMonkey himself, okay? So I stop at challenge number 3. And then now I'm going to move on to, before I let them go, I'm going to introduce them into an algorithm. Now, I'm very familiar with the CodeMonkey platform, so I want you to also be aware as well. Challenge 5 is a very challenging challenge for students. Even though it looks like it's super easy, they have a hard time understanding that there's a certain amount of planning involved here. Okay, so as the students are kind of going through this, you can see I'm solving this with you, but before I do this, I'm going to introduce what an algorithm is, because the students do need to know the sense of term. We'll re-talk about algorithm in lesson number 2. We're not going to do lesson number 2 for the sake of today, but I did want to kind of show you that part of that. Okay, so now I've done those challenges, and now I want to talk to you about what an algorithm is. So an algorithm is a recipe, or I'm sure as you figured out right now, kind of a set of directions. What you put in is what you get out. Or you put something in and you get something out. So think about like chocolate chip cookies. They're not really cookies until I put them in the oven, and when I get them out, they're cookies and they're delicious. Not that raw cookie dough isn't delicious, but I just get a different result than what I put in. And so we just solved challenge number 5. I love to use this video. This is an algorithm video from BBC. My team will share this with you. I'm just going to play a little bit of the video so you can get an idea of what I like to share with my students.
If we want a computer to understand how to do something, we need to give it an algorithm.
Pick up brush.
Algorithm sounds like a big word, doesn't it? But actually, an algorithm is something very simple but important.
Pick up toothbrush.
An algorithm is a list of steps you give to computers to solve a problem or get something done. Imagine that you need to show someone how you brush your teeth so they can learn how to do it themselves. You would need to explain all the little steps you do in the right order so they can understand how to do it without getting confused. The instructions would go like this. 1. Open the toothpaste. 2. Put a bit of toothpaste on the toothbrush. 3. Open your mouth. 4. Brush your teeth nicely. 5. Rinse your mouth with water. 6. Smile. It is important to explain the right steps in the right order so you can get great results.
Okay, so that a video that I like I said, a video that I like to use to kind of share with students. I feel like even middle school students like this video because it's very explicit about what it's teaching there. Okay, so we talk about what an algorithm is, and then I'm going to now assign the challenges to my students. So now if we go to what the student looks like, I just like to show you this because I think it is important so you can understand where we are. Now you can see that the student is no longer frozen, that they can now continue, and they only have access to those challenges that are within the lesson. So just important to note. Oops, sorry. Realized you didn't see that, but now you can see that they are active here and that they have the ability to code, and they're only going to do those challenges that are associated with the lessons themselves. So now let's go back to our lesson that we are reviewing here. Okay, so now we've done our playtime that it had for us to discuss, and it talks about on the left about the stage. So we always suggest looking up the lesson plans before. Even if you're not a super strong coder, it just gives you that really strong sense about what it is to do. You know, I know this, we're always guilty of sometimes flying from the seat of our pants, but it's really good and efficient to check these out beforehand, at least as a guide. So we work through those challenges, and then now we get to the debrief. So what did you learn today? What did you like most about coding adventure? So just really getting them excited. Challenges 0 through 10 are really just to get the students excited and familiar with the concepts. We don't want to start off with something super, super hard to begin with because then they're not going to want to continue. Okay, so then I can end the playtime, and once I end the playtime, I can then mark the challenge or mark this lesson as complete. And when I do so, it will gray this out. Now I'm still working in another lesson, so I just have to make sure I end the lesson before I do that, and then you'll see that it is marked as complete right down here. So just something to kind of note. All right, so now let's get into lesson number 3, which is object-oriented programming. I'm going to move a little bit quicker through this because I think that first part really takes the most time, and so then we're just going to kind of move through here. So now I'm on challenge. Sorry, I tend to do this, mix this up, but that's not what I mean. Lesson number 3, and we're going to do challenges 12. We're basically going to do challenges 11 through 15, and I'll show you exactly kind of what that looks like here in just a moment, okay? So I am going to go through object-oriented programming. So here in the lessons themselves, we have the same sort of setup. The objectives that we're doing here is what they reviewing what they learned in the previous lesson. We skipped lesson number 2. It's just the back half of that intro. Discuss the concept of planning, which we just talked about, the algorithm, and then complete challenges 11 through 15. So here we're going to introduce some brand new terms, the turn 2 and the turtle step. I always like to really talk about these with teachers and really talk about them with students because they really are very hard concepts for them to kind of understand. Same standards, all of that other kind of stuff. Here, the activity in the room is to kind of play, in this lesson, is to play a game of, like Simon says, where you put an object in the room and you have them turn specifically to that object, like in a game of Simon Says. So they only move when it says turn to. So instead of turning right and turning left or turning a degree turn, we're turning specifically to something like you do with your brain. You turn specific, you want to go out the door. I'm not thinking, oh, I need to turn right, turn left. I think I need to go to the door and I need to walk out the door. So same sort of concept here, okay? This one has them write down a map of how they get to school. So what I usually do is I usually have them map out how I get from my classroom to the PE room or something like that in a very step-by-step directions. This is a great place to do pair share with students and just being able to kind of share that information with them, okay? And then sharing that, and they'll find out they have extra steps that are not needed. We want them to have the shortest, most concise set of directions to be able to go through. So now this says, let's go ahead and let's do playtime. And here this says, have them work through challenges 11 through 15 with 2 stars. We suggest the younger grades 2 stars, and we suggest the older grades 3 stars. So something to keep in mind. We'll talk about that. So let's look at challenge number 12, which is what this tells us to do. So in our walkthrough, so I'm gonna make sure I begin the lesson so the kids are seeing what I see. And then I'm gonna click challenge number 12 and we're going to solve this. So here, like I said, I'm gonna debug my challenge here and you'll see that I'm turning specifically to the object. You'll also see here along the bottom an introduction to the buttons. The buttons don't type, they're not drag and drop, they just type out for students. It really helps for those students with special needs, dyslexia, or ELL learners, or even those students that just are not great spellers, so they're not tied down. Anything with the white text next to it also types out, so just something to keep in mind. So here, I don't want to turn to the banana, I want to turn to the bridge, and then I want to turn specifically to the banana. You'll see here that I did not fully solve this yet, but you do see how he specifically is now turning to an object. This syntaxing sometimes can be an issue for students, so just making sure that they check their syntax is kind of important. And then before moving on, what is an object tag? This is pretty important. I visited, like I said, a lot of classrooms and talked with a lot of students, and you know, as we're kind of moving through this, they just really don't understand this concept. So I'm going to do something here at the top, and you can notice there's something different about the code here. Okay, so we have the turtle moving. How do we get the turtle to move? Well, the computer automatically assumes, remember it only has the brain for what we have here, that the monkey is the main character. So the monkey is who's running, or in this set of challenges, is the monkey who is the main, is the main character, which is the monkey. And the monkey is the one who's doing the moving. So we don't have to tell the computer every single time. It is not wrong if we do that, okay? But it is not necessary. So here we have the turtle moving. If I don't have this object tag here, you'll see that the monkey just continues moving. So we have to tell the computer who needs to move. This is a very abstract concept for our students to understand. So it's important for you to also see that too, that we just need to associate what the object tag is themselves. So I always show them this before because it's just very tricky and it's very hard to understand. If you're not understanding, okay, well, I just see that there. I know it needs to, but why does it? Because the computer needs to know. If you don't have the period there, the computer also doesn't know what to do. So we have to make sure that we associate the object tag with what's moving. Okay, after I do that, then I assign the challenges to them. And when I assign the challenges to them, I'm just going to refresh this really quickly. When I assign the challenges to them, they will only have access to those specific challenges. Now, normally this is grayed out, but my internet's a little, getting a little, sometimes with the Zoom, it gets a little tricky. So it's not that it doesn't, it does work in its full way. Just my internet's a little shaky right now. So let's talk about the classroom dashboard and how we track students' progress. So here in the this is the student progress page here. On the progress page, it is a teacher's best friend. It's your best friend. Why is it your best friend? Because it contains all the answers to everything. You don't have to go hunting or fishing or trying to figure out any of those kinds of things. This contains all the answers here. Here you can see when I do the limit progress based on the lessons taught, you'll see that now it only has access to the lessons for which I want them to be doing. Just in that way, it just kind of keeps everyone on the same thing. When I hit free play, it will kind of open it up completely to them. Okay, so you're looking at these stars. We talked about the stars. What do the stars even mean? So a 3-star solution is the shortest, most concise code. A 2-star solution means that they took an extra step to get there. And a 1-star solution means they were able to get the banana or get the object that they needed to, but they just really were not understanding that concept. I like to call those students the struggle bus. So here, how do I figure out even what the answer is? So up here in green are all of the 3-star solutions to every single challenge. So you're not, like I said, not having to go to hunt. You know, when that student comes up to you and you're panicked and you're like, I don't know, why don't you phone a friend? You don't need to phone a friend. You have all the answers right here for you, okay? Also, if a student is struggling, you can click on it, see how many times they attempted a challenge, and you can see the answer in real time, how they solved it, really creating that authentic conversation. Many times I've used this when my kids are struggling and I look at their code and I think to myself, I don't really know. I come back and I look at my solution and then I compare it to theirs, and then I can really have that conversation to really see what it is that they're kind of needing. So the limit progress is really important. You can limit it based on the lesson that you're taught. You can do free play, or you can just do a very specific one. And you'll see that they have no access to that beyond there. Okay, so we worked through this second lesson and really showing them what they need to do here. I just want to note this since we landed here, that this is an assessment challenge. It means that there's no pre-built code, and it's taking what they've learned prior and applying the application here, okay? All right. So here at the end of the playtime, there is also this debrief, and this is doing challenge 14, which we just did together, which is the object tag. So just something to kind of keep in mind there. All right, so what coding concepts did we learn? The step, the turn to, and the turtle step. Something I want to mention really quickly is about the coding concepts. They are all listed here up at the top. I like to call them units, but they're really coding concepts. So first we do our stepping and turning, our turn to turtle, the times loop, and then variables, okay? So it kind of moves through there. So I wanted to show you actually on a challenge itself here, how we kind of understand how that matches itself. So here we have the story map, and each world within the story map has its own concept of which the students are going through. So just something there as well. Okay, so I'm just going to quick talk about skill mode. So skill mode is an extra reinforcement of skills. You saw it right here on the story map. You can access it here or from the main screen. It's basically a reinforcement of skills. So you have a student who is really advanced and you need to differentiate for them. You can put them into skill mode, and skill mode opens up after the end of each coding concept the students have learned. It just is a deeper dive into that. Or if students are really struggling, like when students do variables, I highly, highly suggest that you use the skill mode for them there. Okay. So now we're going to move on to our news and notes here. I know that was pretty quick little intro into everything, but I did want to talk about our newest courses that we have. So our newest course here is the Banana Tales, and Banana Tales is a Python course for students in the older grades, grades 5 through 8. It's really a deeper dive. It's very similar to Coding Adventure in that it moves through a map, but it does work in full Python. We also have CodeMonkey Junior, which all the teachers have been raving about it. All of our teacher ambassadors are super jazzed about it. It is a block-based coding course in which students work through sequencing and loops, and this is for our preschool to early kindergarten age students. Okay, so let's go ahead and let's review our objectives that we went over today. How to run a lesson in your classroom with Coding Adventure, an intro into Coding Adventure, what CoffeeScript was. We talked about Coding Adventure using the lesson mode, what it is, the interface, the lessons. We did lessons 1 and lesson 3, how to track your student progress, where to find the coding concepts, what skill mode is, any news and notes, and now we're going to leave some time here for Q&A. But before I do that, I just want to briefly mention something, and then we'll leave some time here. Over here on the right-hand side are our teacher resources. Something that I like to mention is the coding concepts, which is what I talked about earlier, where you can find those vocabulary for stepping and turning. And then there's all kinds of like video tutorials and things to just kind of note. So I highly recommend looking through that. I think it's very beneficial for you. There's a lot of resources that you're probably unsure of there. Okay. Yes, there are. Okay, so now I'm gonna leave some time for Q&A, so you can leave it in the chat box, and I'm just gonna go to the Q&A here. So if you have any questions, please put it into the chat box there. So I have one question here. Are there lesson plans available for the trial version as well? There are. They're just going to be a limited version because you don't have access to all of the challenges. It will give you the lessons to challenge number 30. One more question, where can I find the unplugged coding activities? So the unplugged coding activities are located in the lesson plans. They're always in the intro. They're not specifically listed like on their own, but they are right there in the beginning. So that's nice there. Okay, I'll just wait a couple. So that's a great question. So what grades is Coding Adventure recommended for? Coding Adventure is recommended for grades 3 through 8. I personally just find that with second grade, it gets a little bit tricky with the variables, but they absolutely can do it. I've worked with many students as far as that goes. And then how many classes can you set up? You can set up however many classes you want. Most of the subscriptions that we have are based on student seats, so it's just dependent on how many you put in a classroom, but the max for each classroom is 50. This next question, assuming previous coding experience, where should 8th graders start? I always suggest that they start from the beginning because you really want to get them intertwined in the platform itself and making sure that they not that they don't understand, but they'll move pretty quickly through the first like at least 30 challenges. Once they get to variables, that tends to be pretty tricky for them. But that's where I would start with them, is just definitely start them from the beginning. And it's fine if they move pretty quickly through that first part of Coding Adventure. Wanda, we will send you a follow-up regarding your question. This program is for grades. This program is for K to 8. Our CodeMonkey Junior is for the younger ages. And then you can start some parts of Coding Adventure pretty early. There is like a scope and things. So if you're interested, we can definitely help you with that. Great question. Brian had a question in free play. He said, I understand that students can work through all of the lessons. Is that correct? It is correct. Unless you limit them, then they can move freely. Just keep in mind that it does move in a linear manner, so they cannot skip around or anything like that. As a teacher, you have the ability to skip around and access things, but they cannot. They have to move in a linear pattern. This is a really great question. Does grade level really matter if they have never coded before? No, it does not. We do not base it on that. I like to think, and we like to think of coding as a language. Like if you're learning Spanish in kindergarten, and if you're learning Spanish like an old lady like me, you will still learn Spanish in the same way. So we don't really like to say that there is a grade requirement. I have another question. The teacher assigns the lessons or it runs on students' level. So if you assign the lesson to them, then they only are working with you in that lesson mode to those specific set of challenges that are in the lesson itself. And then, so that's kind of how that goes. And then it does, if you want them to have free play, like if you want them to just move at their own level, then you wouldn't, you don't have to limit any progress. They can just kind of move along as they go. Okay, so if you have any questions, I see that there's a couple more questions. We'll try to get to your answers after today's webinar. We want to honor your time. Thank you so much for spending time with us today. Directly following this, as soon as we end the webinar, you will receive a feedback form, and in the feedback form will pop up with a, after you complete the feedback form, you'll receive your professional development certificate. So just to kind of keep that aware. All unanswered questions we'll answer you by email, so we'll follow up with you after today's webinar. Thank you again so much for joining us. Thank you, Talya and Zoe, for taking on the questions and answering me with it being so late there. And thank all of you for spending your time with us today. Remember to write code, catch bananas, and save the world. You guys have an amazing day. Thanks.